Good day. This is the 13th video tutorial on Designer program. In today's lesson, we will look at composite cubes. Composite cubes play a very important role in building a strategy. The main advantage of using them in strategies are as follows. They allow not to clutter up the strategy schema, thereby making it more readable and user-friendly. A composite cube is made up of different program cubes that are connected to a schema. This schema performs frequently encountered actions in the program: checks, closing a position, conditions. Accordingly, using a composite cube, we reduce the time to create a strategy. Another benefit of using is that if we ever created an algorithm that performs an action and made an error in it, then when copying the schema of this action, the error will be in all strategies containing the schema. Accordingly, a problem will arise to eliminate the error, and this may take a long period of time. When using a composite cube, it is enough to correct the error in the cube itself, and it will be corrected in all strategies. When composing composite cubes, the union cube plays an important role. Let's create a composite cube and place the union cube in it. The cube combines data of the same type coming from different cubes into one output parameter and passes them to some element, or splits the received data into several elements. Both sockets, input and output, determine the type of data received and passed. The parameter in the settings determines the type of received and passed data. Let's look at the schema in which there is a position cube and an order registration cube. Order registration cube receives data on the position volume for making trades. Enter the strategy window and select our cube in the palette. As you can see, a composite cube has a large number of sockets. At the same time, some input sockets have the same values. To reduce the number of duplicate sockets and make the cube more usable, in a composite cube, select two union cubes. The first cube will receive the strategy instrument value and pass it to the corresponding sockets of position and order registration cubes. The second cube will receive the portfolio value and pass it to the corresponding sockets in the same way. After that, sequentially in the settings of the order registration and position cubes, we will uncheck the sockets item. Let's go to the strategies window. Click refresh. As you can see, the number of sockets has decreased. Only the necessary instrument and portfolio sockets remain. Inside a composite cube, the union cube passes the value to all required sockets. Let's take a closer look at working with composite cubes using the example of a position closing scheme. Create a new composite cube, and let's call it closing position. Let's open the strategy from lesson 9, where the closing position schema was clearly shown. Select the cubes that are responsible for closing position and copy them. Creating a composite cube closing position will make it easier to use in further strategies. Thus, it will reduce time and make repetitive operations more versatile in use. So, we copy the diagram into a composite cube. For closing, select two order registration cubes. Thus, we will make the operation performed by the completed composite cube, and therefore, its further use is possible without additional elements. Assign the trade direction. Connect all the corresponding sockets. Let's move on to the strategy from lesson 9. Select and copy it. Paste it into a new strategy window. Delete the branch with the blocks responsible for closing the position. Select the closing position cube. As you can see, the cube has a large number of duplicate sockets. This is due to the number of simple cubes, which are its composition. Let's bring the cube into the most convenient form to use. Let's move on to the closing position cube. To disable sockets, we need to understand which cubes receive a signal and which are not. Combine signals of the same type via the union cube and uncheck the sockets parameter in the cube settings. Variable cube with a value of 0 does not receive external signals, since it is a constant. Respectively, in the settings, uncheck the socket's parameter. At the variable cube, which receives the position value, leave the trigger to pass the signal to trigger. That is, upon receiving a signal about triggering, the closing position cube will trade. Position registration and position cubes have the same instrument and portfolio sockets, respectively. Data streams can be merged via the union cube. Select the union cube and connect it via the output socket with the position and order registration cubes by setting the instrument data type. Similarly, by selecting the second union cube and connecting it, set the portfolio data type. Remove the checkboxes from the socket's parameter in the position cube settings. Now, the union cube will receive data and passes it to the sockets of the required cubes. This will reduce the number of sockets in the closing position cube. Let's check it out in the schema. Let's refresh. As you can see, the number of sockets has decreased. Similarly, via the union cube, we connect the order registration cubes via the trade price socket. And also uncheck the socket's parameter. We still have triggers for receiving a signal to trigger the cube: price, volume, and portfolio sockets. In the strategy, using the converter, get the closing price and pass it via the variable cube to the closing position cube. Connect the closing position cube with all the required cubes. And remove unnecessary elements of the strategy. If the cube receives a signal from the working hours cube, then this will be incorrect, since the strategy works around the clock. Accordingly, we need to impose an additional condition under which the strategy starts working, only upon reaching 10 a.m. when trading opens. To do this, we need to find out the current time of the current day by applying the converter cube, which will get the data by extracting them from the converter cube, which gets the calendar time value. And comparing the obtained value with the time parameter set in the variable cube. Select the variable cube and set in it the value of trading start time, 1000. Using the comparison cube, we will compare the two cubes with the time value and find out whether the trading has started or not by receiving the signal. We consider a similar schema in Lesson 9. After receiving the signal, it is necessary that the condition is fulfilled that the working time is over and the current time is more than 10 a.m. Via the logic cube, we get a signal that will be passed to the closing position cube about the action and connect it to the closing position cube via the trigger. Select an instrument and run the strategy. Always be attentive to your schema so as not to make mistakes, and do not forget to set the necessary parameters. The program will always tell you where the mistake was made and will highlight the required cube in pink. This simplifies the user's work. Set the AND value in the logic cube. Select the instrument and run the strategy again. So, the strategy trades and works. Thus, we have created a closing position composite cube, which can be used in the future. The sequential creation of similar cubes that perform repetitive operations greatly facilitates the work. It also reduces the time spent on strategy debugging. That's all. Thanks. Goodbye.